Hey everyone, this is Crusoe. I have created a display that shows the lowest accumulator charge level during nighttime up to 13 days, and I'm here to show and give a little explanation about it, how it works, how I built it, and what kind of combinator tricks I used. Let me pause the game for a second. So of course, there are other, probably easier ways to monitor your accumulator charge level, but this is what I came up with. And I'm going to talk about a few things: how to create memory cell, the one I like to use, and why I like to use, I may explain that as well. How to convert a volt signal to a pulse, or actually a double pulse, because we're gonna need a double pulse, using the double pulse to set or reset the memory cell that we're making, choosing the lowest charge or select the minimum. My trick to reset this minimum, so it will find the minimum every day, and what is wrong with the display, because there's also something wrong with it. I don't really think it's wrong, but anyway, I'm gonna explain that too if I'm up there. So the first thing is the memory cell. Let me show this guy here. Now if I actually disconnect that wire here and reconnect it, it will kind of reset. So before I start, I'm just show you the wiring, because I think it's kind of important to see the wires. So the red wire comes from here to here. Oh, I maybe need a bit of more thick pencil. From here to here, and then from here to here, and then on the light, each one of the lamps, and the green, if I can get a green, comes from here to here. Okay, that's how it's connected. Very simple. The data comes into the top combinator on a red wire, and then the setting signal, the X, comes on a green wire, and then oh, I forgot that there is one more wire between here. So the bottom cell is basically the bottom combinators. The top combinator is basically what sets up the memory, and the bottom is basically the memory cell itself. So let's come back to the game here and explain. So each of these combinators set to X equal 1, output everything. X equal 1, output everything. Now how this works: here we have the data. I just set these lamps to show up if D equal greater than 0, 1, 2, 3, and 4. So D is my data. If D is 3, when I give the X signal here, the X will then go to both combinator, and both is set to X equal 1, output everything. So when I set X to 1, these combinators both will put the data on the wire. Now what happened then, the data comes out on the other side. So actually for a second D equals 6 should come out, but the next next frame, the top combinator outputs X equal 1 as well. So on the red wire there will be X equal 2. So the bottom combinator stops outputting the data next. So when I turn this on, it will only show 3. Now, but when I turn off the set signal, it will then still hold the data in this bottom cell, because the X disappear from the green wire here, but it's present on the red wire because the bottom combinator will output X. Now when next time I can even delete this combinator. I just turned it off and it would still hold the signal. Now if the next time a new data comes in, data 1, it's not set straight away, only when I turn on the X. Now what's happening when the X is when the setting signal, the X is present? The X present on the green wire, so the bottom combinator, which has an X on the red wire as well, And this is why I like this memory cell, because the X is present on the bottom combinator. The X comes on the green, so the bottom combinator will stop outputting the old data. At the same time, X in here is just 1 because only the green wire is connected to here. So this one straight away outputs the fresh data, so there is no delay between. One combinator stops outputting the old data and the new one outputs the new data. So when I turn this on, the new data d equal 1 is outputting on the bottom combinator, on the top combinator, until this X is present, and the bottom combinator is not outputting it anymore because in here X is 2. But when I turn off this combinator here, or I'm not doing the reset setting signal anymore, then the top combinator will, which connects to the bottom and the input of the bottom as well, the X disappear on the green wire, 1X, but the other X is here. So the moment this one stop outputting, the next one will output as well at the same time. So the fresh data is on the memory cell. And the reason I like this, because some other memory cells do the way that they first clear the memory and then write the new data, and then that's not very good, because if you have a display showing something every second, then it will keep flashing you every second like this. If you use this memory cell, it will just the data just from the, for example, you're showing your how much iron plate you have in a box or how many robots you have, and if you want to refresh this every second, then if you use this, this memory cell, from one number you just show the next number and there's no flash or something on the display. So that's how this works. Now the only issue, or not issue, but complication with this, that this reset signal, this X equal 1, you need at least for 2 pulses, and it's kind of obvious why. Because if you want to set up a new data, let's say data 4, if I just send this X for only 1 pulse, then the top combinator will output the new data, of course, if the X is here for 1 pulse. So this will output the X here, but the second combinator that still have the X in it from the last data will get X equal 2, and then if the X disappear here, then the new data is not it will be not present on this wire. So so you will be not able to set up the memory cell. It's kind of hard to explain it, but trust me, you need this for 2 pulls. In here we don't have pulls, I'm just turning on and off with my hand. But if you have just for 1 pulse, it will not work. Let me just kind of think about it. Why not? Because I think my explanation was bad on this. So right now we have this off. Let's have a new data, number 2, d equal 2, and the d equal 2 comes in here, and when I turn this off for 1 pulse, this will output for 1 pulse, and the old memory cell will then delete at the same time, and then it doesn't work anyway. I know that. I built that memory cell many times, but let me just think. So X comes here, 1 pulse. So this guy have 2X, this guy have 1X. So this guy outputs the data plus. Oh yeah, the reason this is not working because this one outputs the have the 2X outputs here. Well, I don't want to explain that anyway. I'm kind of confused myself here. I have to think a bit harder on that, and I don't want this video too long. So just just believe me that this memory cell to set needs at least a double pulse on the X, a double signal. I mean, by double signal I mean at least 2 frames. So it's a single pulse will not able to set up this memory cell. And here is the solution how to make a double pulse. It's kind of actually this one is, first of all, how you make a pulse from a health signal. That's what I was saying in the introduction, and I'm gonna talk about how to make a pulse from a halt signal. And maybe you notice that my frames per second is 30. That's because the recording is 30 frames per second, so I can't run the game in, I'm running the game in half speed just to make sure you see the lights flashing, because they only flash for 60th of a frame. So what's this guy doing? The top combinator is a decider combinator which makes passes every signal that is greater than 0, and the bottom one is just arithmetic, which then multiplies every signal by -1. Now let me get my colored pencil here, clean that. So I have a wire from here to here, and then from here to here to the lamp, and also from here to here. And then I have a green wire from here to here, just to make sure we have no feedback from itself. From the arithmetic combinator will not feed back to itself. Okay, and what we're doing here? So let me get my cursor back. So when I output this green signal, the lamp is just set to enable if anything greater than 0. Ignore this combinator on its for a second. So if I output a signal of purple or anything, when I turn this on, the purple signal comes to the top combinator only. The top combinator then sends it to the lamp. The lamp lights up for a single second, because at the same time when the light comes up, this combinator also feeds the arithmetic on the bottom, which then multiplies that blue, purple or whatever signal by -1, and it will then as next frame it will put back on this red wire. So that while this guy will keep sending out 1 purple, this guy will keep sending out -1. So on the red wire will be no signal, and that's why you need this wire green, because if it was red, it was like sending out -1 + 1 -1, it would like flash. So that's how you do it. And to show you, I just turn on this, so you should see when I turn on it should flash. Maybe a yellow was better, it shows better on the screen, I think. So that's how you make a pulse. Now why I have this here? Because when I turn on this, it sends the yellow here, it's still present on the wire, you can see, and the -1 here. But when I turn off this, the top combinator stops working first, so it will not send up the 1 yellow signal, but the bottom one at the same time sends a -1 signal out. And in this case it doesn't matter, because we just control a lamp. But in my thing in there, which we getting to soon, we have to make sure we're not sending some stupid signals. So this -1 signal should gone. It shouldn't be there even for 1 pulse. So instead of connecting this straight to the lamp, I just put a combinator between, which only outputs the positive signal, so the negative signal will not pass. So that's why I have this underneath the lamp. So it's working the same way in here. The only difference is delayed by 1 frame anyway. But so we made sure that there is only positive numbers, positive signals pass here. And as I mentioned, from a halt signal like this, I will need a pulse to set up the memory cell, and I need a double pulse. And how I make the double pulse is here. and basically it's the same, the top and the bottom here. Notice, you have to notice that the top and the bottom here, oh, I can't click on my game. The top, I'm gonna use some yellow color. So the top, and let's use a different color, and the bottom is the same. They are a decider and an arithmetic, and they are all the same. This is all set to send every positive signal. This is all set to multiply by -1. Now the only difference here is why this one just sends one pulse. This will send the pulse here on the green wire, same way. I could connect this green wire to the lamp in this case, but I added again this thing between just to separate the negative signals. So you notice it's the same thing. It will send the yellow thing on the lamp, but instead of the next frame and multiply it by -1 and send it back again, it will just send through 2 more combinators here. I mean 1 more, because this one, I could actually simplify this if I delete that. Actually, I don't need this. Oh, let me. So I'm sending into 2 combinator, and yeah, I can just send it like this. Now I always learn something new. I put it in a, because originally I used the red wire here, and that's why I needed an extra one. But this time I don't use, I use the green wire now. So instead of sending this signal straight to the arithmetic, I'm sending through another decider, which just sends the signal back. This does the same, just passes every signal, but I could just put this not equal 0 to send even the negative signals, but in this case greater than 0 is just fine. So the yellow signal, or whatever color signal I'm sending here, will go to the lamp and then go to another combinator which delays it by 1 frame, and then another arithmetic which then sends it out -1 time. So this combinator here will get the, as I move my mouse, you can see this is still sending out 1 yellow, and this one is a -1, and the 2 adds together on the green wire, and -1 plus 1 is 0, so there will be no light coming up. But when I turn on and off, it should now maybe you can see this light. If I maybe check here first, this one flashes kind of pretty fast. It's just 1 frame. Maybe if I change the game speed, let's say 0.1. now, oh, that's too, oh, I forgot to press the game speed equals 0.1. Now this will be super slow. It will be like 6 frames per second. So when I turn this on, boom, boom, and the other guy, oh, it's super laggy. And the other guy should turn on twice longer. Maybe you can see, turns on and then passes here, and then, okay, this is a bit slow now. Let me put back to half speed. Okay, it's a little bit better. So this guy here now sends a double pulse of yellow signal, and also if I just turn on this and the signals are present, when I'm turning off, that negative signal that's coming out from that guy is there for 2 more cycles. So that's why I have this guy here. Make sure only the positive signal passing. And just to make it even funnier, I made an even longer one. When you have the light up, if we compare to this guy, which comes up for like boop, boop, just for a little second or little moment, and this one now, this one should come up like 1 2 3 4. Yeah, actually I don't need that. I could just do this, so this one will be even longer now. So I can just turn this on and it should show up for a couple of a few moments longer. As you see, by the signal passes on all these combinators, it will keep the light up. And also when I'm turning this off, the -1 signal is here until this whole queue emptied. When the signal stops coming from here, but then this one's still sending, and then stops in here, and then here and here, and one by one they all disappear. And by the time it's going down there, this guy on the bottom would send out like 6 7 more -1s, which we don't want. So that's how this works. And now this is how you actually, this is where I set up the memory first. I showed you just by turning on and off this guy. Now over here I built the same thing, but I have this pulse generator, which turns out I made it okay, I made it complicated here, but it seems in here I made it properly. Yeah, I added an extra combinator here for some reason, I don't know. Over here I just made the same thing, but from this X held signal I'm just generating a pulse the way that we did down here. Okay, I'm just not sure why I have, or maybe I did a triple signal here, I'm not sure. Anyway, if I change the data to 4 and I send the pulse, you see, if I keep this on in here where the memory is set, there should be no signal. Why there is still signal? Maybe use the wrong oh, why I have two arithmetics here? I think I made something wrong here. Anyway, okay, oh yeah, I know, I can see already. I've connected that here. I should have connected this here and here, and then this gives the signal. Okay, so when I change the data to whatever and I'm sending a signal, it sets the memory cell. Okay, I don't know what I built there. So the X is still turned on here. Oops, if I still leave the X on, I forgot to change the data, but let's say the data is 5 and I'm sending the X, so I turn it on, but I don't turn off. So I have a held signal to set up the memory, but I generated the pulse from it because this guy in the bottom here is same I just explained here, is sending the data through this combinator twice, and then from here it sends to here and then here, and then 2 ticks later this guy makes a -1 signal into there and into the green wire, and then that goes through there, and then the only difference, instead of yellow I'm using X here. Okay, I forgot to mention that I'm using the yellow signal here and I'm using the X signal here because I'm not using it to make any color. So how long this will be? 24 minutes already. Oh my god, so I didn't even go to the explanation of the combinator itself. Maybe I'll cut the video into. So what happens here is this X comes to that combinator here and then outputs in here, into this combinator and then goes here and then sets up the memory cell, and then the X comes down here into this combinator at the same, when this one outputs to the arithmetic, at the same time the top one still outputs here, so there will be the double pulse, and then at the turned frame this guy multiplies by -1 will output that -1 times. So it will be, the X will be only present for two frames, 2 cycles, and then it will not disappear, but from here it will be +1, from here it will be -1, so it will be still on the wire, but +1 and -1 will be 0, so it will be not present until I turn this off, and then there will be a -1x on this wire for a 1 or 2 cycles. So that's why we need this guy in here to make sure only positive signals go through. So when I turn this off, it will stop sending this. Now when I turn this off, nothing really happens, just this guy clears out, and I can then use this again when I want. Okay, I've shown this one, so let's get to the display, and I think I'm gonna do a cut here. So maybe I just stop the recording and restart the recording, and I can actually check if it was okay. Okay, so see you in a minute, or see you in the next video.